What's up everybody and welcome to a new series. And in a series we're going to create a command line based Minesweeper game. So therefore let's first see what the final game is actually going to look like. So therefore let me open here the terminal and then here I'm going to run this game.py file. So here first the controls are depicted. So with WASD we can move the cursor, with enter we can reveal the cell, with space we can toggle a flag, and with Q we can quit the game. And then here we are asked what difficulty we want to play, and we can pick between easy, normal and hard. So let's pick here easy. So then this is what the game board looks like. And here at the top we can see how many flags there are left, and here we can see the current time. And then here these brackets, they represent the cursor. So for example, if I then press WASD, I can move that cursor around. And as I do that, here you can see that the time then updates accordingly. So now let's, for example, play here this cell. So therefore I simply press enter. And then here we trigger this floodfill algorithm where we can then see for these cells here how many mines are around those cells. So for example, this cell here will contain a mine. So therefore then we can place a flag by pressing space. And then here this flag is depicted, and here the number of flags goes down by 1. And then here we can, for example, then safely play this cell because there won't be a mine. So then next, let's also see what happens when we make a mistake. So for example, here there will also be a mine. However, in this cell here, there won't be a mine. However, let's nonetheless put here a flag. And now let's hit a mine to see what happens when we reveal a cell that contains a mine. So if I press enter here, then you can see that now everything here turns red. And then here at the bottom, it says you lost. And then here, if you look at the game board, then here you can see those flags are still depicted. So they were placed correctly. However, the flag that we put here was placed incorrectly. So therefore then we have here this red X. And what you also can see is that now all those remaining mines are depicted. So that's what the game looks like. And then here at the end, we are simply asked if we want to play again, yes or no. So let's pick here no. And now let's see what it looks like when we actually beat the game. So therefore, let me just quickly here reduce the number of mines so that it doesn't take so long to beat the game. And then let's run this file again. And then here, let's again play easy mode. And now let's beat here this game. So there will be a mine here and here as well. And then there will also be a mine here. And this will be the last cell that we can play. So let's press enter here and see what happens. And then here you can see that now everything is here depicted in green. And then here it says you won. And then here also the current high scores are depicted. And then here it says we have we have a new high score, and we can enter then our name because we beat the game in 12 seconds. And this was now the top high score. So therefore then if I, for example, enter here SEB and then press enter, then you can see that the high scores now get updated. And again, we are asked if you want to play again, yes or no. So let's again pick no. So this is then what the final game is going to look like. And if you want to access the respective code, then you can go to this GitHub repo here. The link is in the video description. And then here you can download this code. Okay, so this is what the game is going to look like and where you can find the respective code. And now before we start building this game, I want to cover some prerequisites that you need to know about if you want to follow along with the series. So the first prerequisites are simply some Python basics. So for example, some of the basics that I've covered here in this Python tutorial series. Again, link is in the video description. So that is the first prerequisite that you need to know about. Then the next prerequisite are some specific Unicode characters that we're going to make use of. So the first one is going to be the asterisk operator, which looks like this. And this one I've simply used to represent here the mines in the game. Then next we have here the black square character. So this looks like this. And this I've used to represent here those hidden cells. Then we have the black flag character, which looks like this. And if this I've simply used to represent those flags. And then lastly, we have here these box drawings characters, which I've used to create here this border around the game board. So those are the Unicode characters that we're going to make use of. And then we're also going to make use of some ANSI escape codes. And most of these I've already covered in another video. So again, I will just put the link to that video with the respective timestamps into the video description. And the only one that I haven't covered yet is here this escape code for underlining. So with that, you can underline some text. So for example, if I say here print hello world and then run it like this, then nothing here is underlined. However, if I now use here this escape code for underlining and put it at the beginning of the string, then if I run it like this, then now here this whole string is underlined. And then, for example, if I use here this escape code for the format reset and put that after the hello and run it like this, then now here only this hello gets underlined. So this is how this underline escape code works. And these are then all the ANSI escape codes that we're going to use throughout the series. And then the last prerequisite are some libraries that we're going to make use of. So the first library that we're going to use is this time module. And from that, we're going to use the sleep function and the monotonic function. So the sleep function, again, I've already covered in another video. So I'll just put the link to that video into the video description. So therefore then let's go straight here to this monotonic function. Namely, what that does is it returns a floating point number representing an unspecified reference point. And this then can be used to measure the elapsed time. So for example, if I import here the time module and then run this monotonic function, then you can see that it returns here this floating point number. And this then we can store into a variable called start. So then if I run it like this, then now we can use the start variable to measure how much time has elapsed since we created this variable. So therefore then let's simply call this monotonic function again. And then we're going to say minus the start. And then if I run it like this, then you can see that now 15.45 seconds have elapsed. And if I run it again, then now we have 22.36 seconds. So this is how you can use this monotonic function to measure the elapsed time. Then the next library is going to be the random module. And from that, we're going to use this sample function. So to demonstrate how that works, I've prepared here a list. So let's here first then import this random module. And then here is this list. So this simply contains numbers 1, 2, 3, 4, 5. And now let's use this sample function with this list here. So therefore then we're going to say random.sample. And then let's first open here the docstring to see what the function does. Namely, what it does is it chooses k unique random elements from a population sequence. So the elements are going to be unique, so there are no duplicates. And first we have to specify here the population. So in our case, this will then be the list. And then we can specify how many elements we want to sample from that list. So in our case, let's pick here 3. And then if I run it like this, then we get here, in this case, this list containing 5, 3, and 1. So there are no duplicates. And then if I run it here again, then now we get a different list. This time we have 3, 1, 4. And if I run it the third time, then now we get here this list containing 4, 5, and 3. So this is how this sample function works. And then the last library is this msvcrt library. And from that, we're going to use this getCharacter function. And the purpose of that is to read keyboard input. So to demonstrate how that works, I've prepared here this code snippet. So let's paste it here into this Python file. So here what I'm doing is I'm importing this library. Then here I create a while loop where I say while the key is not equal to Q. And then within the while loop, I say that the key should be equal to the return value of this getCharacter function. And then here I simply print that key. So now, before we run this code, let's first look at the docstring of this function here to see what it actually does. Namely, what it does is it reads a key press and then returns the resulting character as a byte string. So that's why I put here the B in front of this string. Okay, so now let's run this file. So therefore then let's say here Python and then scratchpad.py. So now if I run this, then as you can see, it now waits for my keyboard input. So for example, if I press here an A, then it returns now here this byte string A. If I press then an S, then it looks like this. Or if I press, for example, enter, then enter would look like this with the backslash and an R. And space, for example, looks like this, where we just have here this empty string. So this is how this function generally works. However, there are also some special keys. For example, the arrow keys are such special keys. So for example, if I press here the up arrow, then we get here 2 results back. So we have here the special character and then here this H. And then if I press here the left arrow, then we again get a special character and this time the K. With the down arrow, we get here the P, and with the right arrow, we get here the M. So now, to understand what's going on, let's again look at the docstring. So therefore then here, you can see what it says, that it says here, if the pressed key was a special function key, then this will return here the special key, and then the next call will return the actual key code. So if you want to use the arrow keys in the game, what you need to do is you need to call this get character function twice. So therefore then what you need to say here is if key is equal to this special character here, so let's simply copy this and then put it into here. And then here what we want to do is we simply want to call this function here again. So now if we run the file like this, and then here press ASD, for example, then we get the results that we had previously. However, if I now press the up arrow, then this time we only get here the H and not here this special character. And then here if I press the left arrow, the down arrow and the right arrow, we get here the respective key codes. Okay, so this is how this get character function works. And then here I also have a side note. Namely, this states that the msvcrt library is Windows only. So if you are using Mac OS or Linux, then you would have to use the Terminus and the TTY libraries. And then the code would look something like this. However, I couldn't verify that because I'm only working here on Windows. Okay, so those are then the libraries that we're going to use throughout the series. And with that, then we've covered now all the prerequisites that you need to know about if you want to follow along. So with that, now we can start working on the game, and we're going to start with the basic game mechanics. And more specifically in the upcoming video, we're going to start working on the game grid. So thanks for watching, and hopefully I'll see you in the next video.